students, from last class onwards we are discussing the lesson acceleration. Okay, so in this class let us see the difference between mass and weight. Okay, so now mass and weight, how it varies on different planets, even on the moon and on earth, and even weight. Okay, let us see that. So in previous class we already found the value of acceleration due to gravity, that is 9.8 meter per second square, even the formula also. And also gravitation on moon also we found. So gravitation on earth is 6 times more than the gravity on moon. Means it means what, the earth is dragging us with the more force than the moon. Okay, so gravity is 6 times more than the gravity on moon, means where we can feel the moon more weight on earth. Okay, so earth is dragging us, or it's attracting towards towards earth with a more force than the moon. Okay, so let us see what is the difference between mass and weight. Okay, so mass is nothing but difference between mass and weight. Okay, so what is mass? Mass is nothing but the amount of matter contained in a body. Okay, suppose if I say 1 kg of sugar, means that sugar contains how much of matter? 1 kg of matter. Okay, so let us see or write here mass and weight. Okay, see, in most of the times we use weight instead of mass. Actually we have to say weight in newtons, but we'll say what is your weight, means in 50 kgs, 60 kgs, or 40 kgs, like that. Okay, so let us see the difference between mass and weight. Okay, so mass is nothing but the matter contained. Okay, the amount of matter contained in a body is called a mass. So what about weight? Weight is a weight of an object is the force with which it is attracted towards the earth. Okay, so let us see. Mass is nothing but mass is the amount of matter contained in a body. Okay, suppose say if I say 1 kg of sugar, means this vessel contains 1 kg of sugar, means 1 kg of matter. Okay, so what about weight? Weight of an object is the force with which it is attracted towards the earth. Okay, weight of an object is the force with which it is attracted towards the earth. Okay, so what is the formula for mass? There is no formula for mass. Okay, if you measure a particular object, how much matter it contains, that becomes the mass. But what is weight? Weight is nothing but a force. Okay, so force is nothing but it contains certain mass, right? Okay, mass into this g is nothing but acceleration due to gravity. Okay, g is nothing but acceleration due to gravity. Okay, so these force, we can say that is a weight. Okay, weight is equal to mg. G is nothing but acceleration due to gravity. This is the formula for weight. Okay, so from this formula we can derive the formula for mass. Okay, if suppose if he given a weight of a particular person or a particular object, he may ask us to find the weight, mass. Okay, so at that time we can find using this formula. So from this we can say that mass is equal to mass is equal to weight by g. Okay, here g is nothing but acceleration due to gravity, that is equal to 9.8 meter per second square. Okay, so mass is equal to weight by acceleration due to gravity. Acceleration due to gravity value g is equal to 9.8 meter per second square. So these g value is different on different planets. Okay, but capital G, that is universal law of gravity, is a constant value everywhere. Okay, so SI units for mass is nothing but a kg. Okay, SI units. So SI units for mass is kg and SI units for weight is newtons. Okay, and mass is constant everywhere, whereas weight is not constant everywhere. Okay, so mass is constant everywhere. Okay, and suppose if I say mass on a earth is 1 kg, it's same the mass of the same object on a moon also. Okay, so but weight is not a constant. So weight is not constant everywhere. Okay, so suppose say a object is weights, see object mass is 1 kg, what about its weight? So 1 kg object, it is a mass. Okay, so what about weight? 1 kg into 9.8 meter per second, that is equal to 9.8 newtons. Okay, the same object weight or mass is 1 kg 1 kg. Okay, mass is equal to 1 kg, but weight is nothing but, if we are multiply, what is the formula? Mass into acceleration due to gravity, 1 kg into 9.8, that is equal to 9.8 newtons. Okay, so let us see weight on earth and weight on moon. Okay, same object, how much it weighs on a earth and on a moon. Okay, see weight on earth and weight on moon. Okay, so we already found the formula in last class. Force of attraction is equal to g into m1 into m2 by d square. Okay, d square is nothing but distance between those two objects, and m1 and m2 are the masses of those two objects. Okay, suppose see the same force. Okay, is force is nothing but already weight we just now derived, right? So weight of a moon is equal to, weight of moon is equal to g g into m. Small m is the mass of the object, and capital M is the mass of the moon by r square. Okay, r square is nothing but a moon radius. Okay, so it's a moon radius. Okay, so next weight on earth. Okay, weight on earth is equal to g into small m and capital M, that is the mass of the earth by r square, that is radius of earth. Okay na? So I'm finding the ratio of the weight of moon by weight of earth. Okay, so let us find the weight of earth and weight of moon ratio. Okay, so to find the ratio, just divide. Okay, always ratio is nothing but divide. Okay, so weight of a moon by, see Wm means weight on a moon. Okay, next weight on earth, We, that is equal to Gm and capital M, mass of moon by radius of a moon divided by g small m capital M E by r square E, means radius of earth. The small m g cancel. So what is the left ratio here? Capital M mass of the moon by radius of moon into radius of earth square by mass of earth. Okay, so this is the left ratio. So now substitute the values. Mass of the moon is equal to 7.8 36 into 10 to the power of 22. Okay. See, mass of the moon is equal to 7.36 into 10 to the power of 22 into kgs into radius of the earth 6.4 into 10 to the power of 6 whole square. Okay, radius square. Next, radius of the moon 1.74 into 10 to the power of 6 whole square into mass of the earth 6 into 10 to the power of 24. Okay, so if you found this value 7.36 into 6.4 into 6.4 divided by 1.74 into 1.74 into 6 into 6. Okay, here 10 power 22 into 10 power 12 into 10 power minus 12 into 10 power 24. Okay, here. So if we calculate this value, you will get 1 by 6 approximately. Okay, so 1 by 6 approximately. So weight, what is this ratio? Weight on the moon by weight on the earth, that is equal to 1 by 6. Okay, so weight on the moon is equal to weight on the earth by 6. Okay, weight on the earth by 6. So weight on the moon. Okay, so weight on the earth is equal to weight on, so weight on a moon is equal to weight on earth by 6. Okay, so but mass is nothing but a same value, either on a moon or either on earth. Okay, mass is same. Weight on a earth is nothing but earth is attracting you or an object towards it. Okay, so that is the weight. Even the weight on a earth, moon also, the amount of force with which the moon is attracting the object towards it. Okay, so this is a weight. Okay, so formula to find the weight on a moon is equal to weight on earth by 6 times. Okay, so let us see one example. Okay, see, suppose mass is 60 kgs. Okay, mass on earth and mass on earth and mass on moon. Okay, moon is 60 kgs and 60 kgs. Okay, 60 kgs. So what about the weight on earth is equal to mass into g, right? Okay, mass is nothing but 60 kgs into g value 10, approximately will take 10, so that is equal to 600 newtons. Okay, next weight on a moon is equal to weight on earth by 6, right? Okay, that is equal to 600 newtons by 6, that is equal to 100 newtons. Okay, here the moon is attracting the particular object or you with the force that is equal to 100 newtons, but earth is attracting towards itself with the force that is 600 newtons. Okay, and then next let us see the shortcut to find this formula. If you get an exam, you have to do this calculation, but if for remembering purpose or for shortcut, so weight on a moon is equal to mass into gravity, acceleration due to gravity on moon. Okay, and weight on earth is equal to m into ge. Okay, m into ge. So let us find the weight on moon by weight on earth is equal to m gm by small m ge. Okay, small m cancel, that is equal to gm by ge. Okay, so this is gravity's ratio, right? Yes or no? So we already found that gravity on moon and gravity on earth is equal to 1.62 by 9.8. See, we already found this value, that is equal to 1.6. we already got, right? So here substitute weight on moon by weight on earth is equal to 1 by 6. So from this formula, from these we can derive, right? So weight on moon is equal to weight on earth by 6. Yes or no? This is shortcut. If you get in a bits or for 2 marks, you can do this. Okay, or even you get for 1 mark also. This is a formula to find the weight on a moon and weight on a earth. Okay, so let us see one problem. Okay, clear, understood clearly, right? Okay, let us see one problem. Okay, An object of mass is an object is of mass 1 kg. Okay, so and what is the mass on earth? What is the mass on earth and mass on moon? Let us find this. Okay, and what is the weight on earth and moon? Okay, so for first question, so mass is constant everywhere, we already found, right? We already know this. Mass is constant everywhere. Okay, so if mass is constant everywhere means mass on mass on earth is equal to, so let us take 10 kg. Sorry, mass of an object is 10 kg. So mass on earth is equal to 10 kg and mass on moon is also is equal to 10 kg because mass is everywhere same. Next, weight. Let us find the weight. Okay, weight on earth. Weight on earth is equal to, what is the formula? Mass into acceleration due to gravity. Okay, so here I am taking acceleration due to gravity, value 9.8. okay, approximately will take sometimes as a 10. Okay, so you may take 10 or you may take a 9. Okay, I am taking here 9.8, sorry, 9.8 or 10. So 10 into 9.8. okay, so meter per second square. Okay, here 10 kg, so that is equal to 98 newtons. Okay, next, weight on moon. Weight on moon is equal to weight on earth by 6, right? Yes or no? So 9.8 newtons by 6, that is equal to how much? You will get 16.33 newtons. Okay, let us find the value. Okay, this you will get. So weight on moon is equal to weight on earth by 6, that is equal to 98 newtons by 6, that is equal to 16.33 newtons. Okay, so this is a difference between mass and weight. Okay, so weight is nothing but the force, the amount of force which is attracted towards the particular planet, that is either maybe moon or earth. Okay, so in this lesson, see, we found the gravitation, acceleration due to gravity and universal law of gravity and everything, right? Okay, so let us discuss some more things. So a few people rotate the volleyball ball on a finger, right? And a few people balance the scale, iron scale or metal scale on a one finger, right? So what they are trying to do, they are trying to locate a center of gravity. Okay, so they are finding, or they are trying to locate their finger at a center of gravity. So take a spring balance and suspend it to the ceiling and put some weight to it. Okay, so what we are doing, we took a spring balance and suspended it to the ceiling and put some weight on it. So note the reading of the spring balance. Okay, so we are checking the mass of the uh, object while falling or while freely falling. Okay, so note the reading of the spring balance. Now drop the spring balance with the load from the ceiling, certain height, to fall freely. Okay, so carefully observe the changes in the position of the indicator on the spring balance scale while it is freely falling. Okay, so the reading becomes 0. Okay, so see, what we are doing here, we took a spring balance and suspended some weight, and initially we measured it, and we dropping the spring balance along with the load from a certain height, and we are observing changes in the position of an indicator. So on the balance scale, while it is freely falling, its reading becomes 0. So suppose a man jumping into a swimming pool from a certain height. Okay, he feels weightless. While we are coming downwards in a lift, also we'll feel weightless. Okay, in see, you can see in some exhibitions that spinning wheel. Okay, so that wheel. Joint wheel. Okay, in joint wheel also, while coming downwards, you may feel while falling. Okay, we may feel weightless, we feel weightless. Okay, so when the body falls freely, then it experiences weightlessness. Okay, we feel that no weight is will feel weightlessness. Okay, so if any body is falling freely, then it experiences weightlessness. Okay, so what we said here, freely falling body, when a body falls freely, then it experiences weightlessness. Okay, it experiences weightlessness. Okay, so when the body falling freely. Okay, so even in the weightlessness condition, there is still a gravitational force act on the body. Okay, causing downwards acceleration, yes or no? Okay, so but because there is no support force, the weight appears to be zero. Okay, so we already said while freely falling, it it becomes a zero, right? Why this becomes zero? Because there is no supporting force. Okay, so because there is no supporting force, the weight appears to be zero. Okay, so locating the center of gravity. Okay, so with just now I already said, right, balancing is nothing but locating the center of gravity. Okay, so balancing a particular object is nothing but we are locating the center of gravity. So take a meter scale and suspend it from various points. Suspend it from its midpoint. Okay, try to balance on your finger a metal scale or a iron scale, whatever may be. So try to place your finger in a different positions. Okay, let us take a, this is a scale. Okay, so these arrows indicates what balanced, see the force towards the gravity. Okay, or acceleration due to gravity, these arrows indicates. Okay, so suppose place your finger here and place on a different positions and try to place in the middle. Okay, so what happens if you place on the middle? Okay, so let us consider this is balanced. Okay, balanced up, so this is balanced upward ports at a single point. So it's nothing but the total weight of this scale is balanced at a single point, that is in the midpoint. Okay, balanced upward force due to the finger. What is this? Balanced upward force due to finger, and here downwards weight. Okay, these all of arrows indicates weight. So this total scale weight is balanced at a single point, that is here, balanced upward force due to the finger. So the center of gravity of any freely suspended object lies directly beneath the point of suspension. Okay, so the center of gravity of any freely suspended object lies directly beneath the point of suspension. So what we are doing is suspend it from various points and suspend it from the midpoint. The center of gravity of a uniform object such as meter stick, is at its midpoint. Okay, uniformly object always at its midpoint. The stick behaves as its entire weight was concentrated at that point here. Okay, so the entire mass, the entire weight was concentrated at the point. The support given to the single point gives the support to the entire stick. Okay, so here we are giving support in the middle point. This gives the support to the entire stick. Balancing an object provides a simple method of locating its center of gravity. Okay, so what here we are doing? So balancing balancing an object provides a simple method of locating its center of gravity. Okay, center of gravity. So, the many small arrows represent the pull of a gravity all along the meter stick. And all of this can be combined into a resultant force acting through the center of gravity. Okay, so the center of gravity of any freely suspended object lies directly beneath the point of a suspension. Okay, so that's all for in this class. So in next class we'll see the totally problems part. Okay, if you miss any video of this class or any lesson, try to go to my YouTube channel. Okay, and watch all the videos. Okay, so these are very important, right? Yes or no? Okay, so for even this class and even for further classes, okay, don't miss any video. Okay, if you miss any video, go to my YouTube channel and try to watch the video. Okay, so for exam point of view, uh, already syllabus given in the group, right? Force and sorry, matter around us and motion. So we already completed the two lessons. Okay, yes or no? So if you missed any video, see in my channel, in the playlist I created a playlist. In that you every video is available. Try to go and refer. So before exams we'll do some more problems on the motion. Yes or no? So problem part is there, more problem part is there in motion lesson. Let us discuss some more problems in that lesson. Okay, so thank you.